This is an added layer of security for the front end and the surface of the web application, known as input validation or whitelisting. As you can see here, we've added some parameters. The ID number has to be 13 digits. The account number has to be 7 digits. And the user has to have a strong password of 8 characters, 1 number, and 1 special character. This ensures that the password is strong and that the user has a unique password, and prevents attacks such as SQL injection and cross-site scripting. Now let's try and register a user. Now we test our input validation. Let's enter a username, the user's full name, an ID number, an account number, and the password. Oh, looks like the ID number has to be 13 digits as shown by the prompt. The account number has to be 7 digits. Looks like we do not have a strong password. We need to enter a strong password. Now we've registered successfully. Now we log in. Enter our 7-digit account number and our strong password. Login successful. Now we move on to making a payment. Select our bank. We add in our account number, the SWIFT code, the city of the bank, the currency, and the payment reference. As you can see, we need a 7-digit account number. Let's try and make payments. Yes, the SWIFT code has to be 5 digits. That's the standard for all SWIFT codes provided by SWIFT. Payment successful. As you can see, all our details are here. The account number, the SWIFT code, the amount, and the status. All of this ensures that the user enters the correct account number, that there are no mistakes made, such as payments to the wrong account, and ensures the safety of the user and prevention of the aforementioned attacks such as cross-site scripting, command injection, and SQL injection. Thank you.
Alright. Our connection string in the env file allows us to save information from the website. It allows us to save things such as users, the passwords, and the documents or the payments made. Here's the code which allows us to hash our passwords in the database, and here is the input validation. So now when we log out and register again, let's register. Okay, registered, let's log in. Okay, we're logged in. When we go to our database users, we can see a password has been hashed. Now, when we make a payment, payment has been saved. It displays here. Go to Mongo again, refresh. As you can see, a payment has been saved.
On the backend, I'm using Node.js with Express. Normally Express runs on a plain HTTP, but I've configured it to run on HTTPS by generating an SSL certificate and private key. In my server.ngs file, I load the certificate with Node's built-in HTTPS module and create a secure server. I've also added a small HTTP to HTTPS redirect server, so even if someone tries to connect over HTTP, they automatically redirect it to HTTPS. This ensures all communication between the front end and back end is encrypted. On the front end, built with React, I connect to the back end using fetch requests. The API base URL is set in an environment variable called React underscore app underscore API underscore URL, which now points to the link which you see. That means all API requests like registering and logging in are sent securely over HTTPS. And now we move on to the website. So when I show you the website running here, notice the lock icon in the browser, which indicates the connection is secure, which protects sensitive data like usernames and passwords during logins or registrations.
Good day, I'll be explaining Helmet and XSS protection. Helmet is a security middleware for Node.js and Express applications. It helps protect your web app by setting various HTTP security headers automatically. Helmet sets HTTP response headers that make browsers behave more securely. It reduces information leaks and blocks certain attacks before they even reach your code. XSS protection stands for cross-site scripting. It is a type of security attack where hackers inject malicious JavaScript into web pages that other users see. XSS protection means adding defenses that stop malicious scripts from running the user's browser. Now, these are our dependencies that we use to protect our web browser. Now, I'm going to show you an extension for Postman to show me all our Helmet protections. As you can see, this is our helmet. Our XSS protection is set at 0. Thank you.
Employee section, going to sign in into the employee portal. Okay, now that we are logged in, you can see that there aren't any payments. You are logged in as employee. Now we're logging out. Logging in as a customer. Okay, now we're gonna make a payment. Okay, we made a payment. Okay, there it's showing. And the status is pending. Now we're logged out and signing in to the employee portal again. The employee can see the payments made. They can accept or decline the payment. We're going to accept the payment here. Sign back out and log in as a customer or user. The user will be able to see it's been accepted. Let's make another one. And another payment. Also pending. Okay. Employee portal sign in. With this payment, we will decline. There we go. Payment has been declined. The user will be able to see all the payments if it's been accepted or declined. You will now delete.
Hello, today I'll be explaining our employee.mgs code. So I'll be explaining the key features. As you can see, our first feature is our rate limiting. This rate limiting protects the user's input against brute force login attacks. So if the user attempts to log in more than 3 times and fails, there will be a 15-minute cooldown time. Then moving on to our base 64 password. So it's very simple. This prevents storing raw password text in the code. So yeah, then moving on to our JWT token, which is our JWT secret token. This enables security authorization when the employee is logging in. Then moving on to our cookie-based authorization. This keeps session tokens on the client securely. Sorry. Then moving on to our middleware, which is over here. This ensures only logged in employees can access certain routes. And last but not least, our payment management, which is over here. which they also which allows employees can can view which gives the employees the privilege to view and update payment statuses. Sorry, and thank you.
Employee part, the security check. If you enter the wrong information, you won't be able to sign in after 5 minutes. So let's check this. Invalid, okay. And for the final time, account locked for 5 minutes. These are the payments paid. As you can see, the status is pending. Going to verify and decline the one. Okay. Status is pending. If you refresh it, it's going to say accepted, and declined. The employee's password is going to be hashed. And the user sign-in or user passwords are all hashed.